So now we are looking at problem number 4 in chapter 1 of your textbook. So what this problem says is that on side BC of triangle ABC, point A1 is taken so that BA1 to A1C is 2 to 1. So that ratio is 2 to 1. And we want to know the ratio in which median CC1 divides segment AA1. All right, so our first task is to translate all of this. So first thing I'm going to do is I'm going to draw a triangle. Notice it doesn't say anything about this triangle being a right triangle, so I want just an arbitrary triangle, ABC. So I'm going to draw it like this, A, B, C. And then on side BC, we have point A1, so that BA1 to A1C is 2 to 1. So basically the idea is that this distance should be twice as long as this distance. Okay, so hopefully that's clear. Right, so these are all equal. And then we want to know the ratio in which median CC1 divides segment AA1. All right, so we talked about in class how a mid-segment is drawn from the midpoint of one side to the midpoint of another side. A median is what we call it when we draw a line segment from a vertex to the midpoint of the opposite side. So median CC1 means C1 is at the midpoint of AB, and so that's what we're drawing here, okay? And we want to know the ratio in which this median divides segment AA1, yeah? So a couple of things here. We need to give a few points some names to make our work easier, right? So since we're trying to figure out the ratio that this median CC1 divides AA1, it'll be helpful to have a name for this point, and it'll be helpful to have a name for this point. So I'm going to call this point D, and I'm going to call this point E. Cool. All right. So now what will be helpful will be to draw one more segment. So I'm going to draw segment C1D. So I'm allowed to do that because 2 points define a line. We can always construct either a line or a line segment between 2 points. Okay, so that's helpful. And so then what do we know? Well, segment C1D happens to be a mid-segment of triangle AA1B. So hopefully you see that. C1 is the midpoint of AB, and D is the midpoint of A1B. All right? So mid-segment, mid-line, same thing. So our mid-segment theorem tells us that because C1D is a midsegment of triangle AA1B, it tells us that C1D is parallel to A1, so it's parallel to the third side, and it's half as long. So we get that. So C1D is equal to half of A1, right? Okay, so we have that information. And then remember also, of course, we have that CA1 is equal to A1D is equal to DB, and AC1 is equal to C1B. Right? So we had that information to begin with. Okay, so now let's consider another triangle here. Let's now consider triangle CC1D. Okay, so in triangle CC1D, we can see that because these two edges are parallel, and because A1 is a midpoint of CD, that means that this segment A1E is necessarily going to be a mid-segment of that triangle, and so therefore E is a midpoint of CC1. So the important thing here is that I want to make the statement that A1E is a mid-segment of triangle CC1D. And so again, we can use our mid-segment theorem to tell us that A1E is half as long as C1D. Okay? And I'm going to pause for just a minute. Okay, so sorry about that. So A1E is equal to half of C1D. All right, so if I take this statement, this statement combined with this statement, I don't really need that comma in there, then I can see the following. So, oh, what did I just lose? A1. All right, so I can see that C1D is equal to twice A1E, and A1 is equal to twice C1D, which means it's equal to 2 times 2 times A1E, or A1 is equal to 4 A1E, or we can say that the ratio of A1 to A1E is equal to 4. So what that means is that this whole A1E is 4 times as long as A1E. And so a couple of different ways you can think about this. We could say, think about A1E as X. And so that means that AA1 would be equal to 4x, and AE is 4x minus x, which is 3x. And so that's one way we can arrive at this ratio of those two segments. So we can say AE to A1E is equal to 3x to x, or 3 to 1.